Hi, so today I'm going to be taking you through an example, MLOps pipeline, which will help you train and deploy a machine learning model to help you detect anomalies in video feeds. We're going to do this with Visual Studio Code, Azure Machine Learning, and Azure DevOps. So in the first step here, you'll see I have a regular Python script that I'm using to take my input video feed, split it into individual frames. After I've split it into individual frames, I'm going to take these frames and resize them and split them into my test set and my validation set. Once I've done that split, then I can go ahead and start the actual training process. Here's my training code. So we're using an open source library called Pred to do the training. Here I'm defining arguments. So once I've parameterized and published my training job as a pipeline, I can do things like use transfer learning from previous versions of the machine learning model. Can have this exact same code run locally or run in the cloud. For this example, we're going to be running in the cloud. And there's my code to do the actual transfer learning, which basically we'll see if you've trained a model before on this data set or a previous version of it, and use that to help bootstrap and speed up the training process. And you can see there, that's where I'm taking the reference. Again, this is all just normal Python code that a data scientist would be familiar with writing for doing the model training process flow there. So, and here I'm just doing some more investigation. Now, once I've got the code established, I'm going to actually look across all the different models that I trained because I'm going to be doing a hyperparameter sweep. And I'm going to choose the best model, so the one with the minimized loss metric, and I'm going to register that model with my machine learning workspace. So once the model is registered, then I can go and deploy it. Now, what I'm doing here is I'm going to actually first make sure I have the compute targets set up so that when I go and run my training job, it works end to end. And then once I've done that, if you scroll down here, you'll see I'm defining different references. So I'm going to be looking in my blob storage account for video feeds to appear in that folder. Now, those Python scripts you saw earlier, I just stitched them into steps that go into my machine learning training pipelines. There's video decoding, data preparation. In this case, I can pull in a custom base container image if I want to use it for training. And I'm using a mix of CPU and GPU computes. So I use CPUs for splitting the video frames, GPUs for doing the actual deep learning, and then come back to CPU for the model evaluation step. Here what I'm doing is I'm creating the actual machine learning pipeline, and then I'm going to publish it as a REST API and set up a schedule on it. So as new data feeds appear, it will go ahead and try to train a new model automatically. Now, I'm over in my workspace. You can see here's all the experiments that I've been running. Here's the experiment that was created for the first data set I fed in. So you can see I've got different types of runs associated with it. If I look into the run, you saw those 4 steps. So they're actually described and expressed as a graph, and you can see the types of compute that they ran on and what actually happened inside each of the steps also. So, go back to the experiment here. And then if I look into specifically what happens when I do a hyperparameter tuning job, one of the cool things we'll do for you is actually we'll automatically start to cancel runs when we're doing a sweep across the hyperparameters to make sure that we're not wasting compute on, a model variant that we know is not going to be better. Now, when it comes to deploying and releasing the model, what I can do is just go in here and use Azure DevOps to create a release pipeline, just use an empty template. I can define different artifact types. In this case, I'm going to drag in 2 types. One, I'm going to add a machine learning model. So I just go in here and select my machine learning workspace. And then I choose, the specific model name that I want to run it on. Once I've set that up, now I'm also going to add in the any inference code that I want to bring in. So in this case, I've got an Azure repo with my inference code sitting inside of it. Just going to add that in, pick the source repository, great, and pull from latest. So go into default branch here, go into master, great. Now that I've set that up, I just go into the release pipeline itself, and I can go and define the task that I want to execute. So first thing I'm going to do is install the machine learning CLI extension. So again, this is just install the AZML extension. Not too complicated. Let's put the scripts in line, so it's fairly obvious what's happening here. Now, once I've installed the extension, I'm just going to use a single line of CLI command to deploy the model. So in this case, I'm defining the workspace, the service. Those environment variables there are tied to the model name and version. And I have some configuration files in my Git repository that tell it things like how much CPU and memory to give the model when I go and deploy it. Cool. So now I've saved the release. I can go ahead and kick one off. So this would be your sort of first cut at doing your production deployment of the model, and you can see there the version of the model and the code. So I'm going to go ahead and create this, and once I've created it, just waiting a second here. There we go. Okay, so the model has been created. If I look into the stages, I can see what the step actually did. So if I click into deploy the model, I can see that, okay, the model was deployed to a container instance. There's the REST API, the model's healthy. And now I can automate the pipeline. So when new versions of the model come in and are registered, or somebody changes the code, it'll let me automatically kick off a release pipeline. So I can configure, there we go, whenever new code is registered into the master branch. All right, so I've got new inference code, or a new model's registered in the workspace. Then I'll go ahead and automatically kick off the release pipeline. And you can do all the stuff you can normally do with Azure DevOps in terms of configuring multi-step, multi-phase releases as well. So this is just a quick example showing you how to do automated model training and model deployment with Azure Machine Learning and Azure DevOps.